Good morning, everyone. So we're going to go over 1 through 4 from yesterday. So here we have our position graphs and then our velocity graphs. So remember here, slope equals velocity, right? And here, slope equals acceleration. Always remember those things. So we take a look at this first one. We have a constant velocity, so we're going to have a slope, right? And it goes from 0 to 10, and it takes 10 seconds to do so. Oh, actually, it doesn't say how far. We can go anywhere. We just have to move forward for 10 seconds. So I'm just going to do this. Okay. And then we remain at rest. So if we're at rest, we have no velocity, which means we have no slope. So no slope is a flat line. All right, so that's what the first one should look like. Constant velocity, linear line, no velocity, flat line. All right, so now we're going to do this same graph, but now we're looking at it in terms of acceleration. So we are starting from position 0. That has no bearing on this velocity graph. But what we do know is that we're moving forward, right, with a constant velocity. If our velocity is constant, we aren't accelerating. So we're just going to have some velocity for 10 seconds. And then we remain at rest. So then for the last 5 seconds, so we have to come down real fast, right? This part's not super important. And then we go flat because now we're at rest. So we're definitely not accelerating again. And we know our velocity is 0. So we put the line for velocity on the 0 axis. So that is number 1. All right, so let's look down. Now we got number 2. All right, starting from position 20, all right, an object moves backwards with a constant velocity until they reach a position of -20 in 10 seconds. So they start at 20. They get all the way to -20, and it takes them 10 seconds. And again, it's a constant velocity, right? Which means we have a slope, and the slope is constant in a position time graph. And then what do we do at the end? We stop moving. If we're not moving, there's no velocity. If velocity is slope, no slope is represented by a line that is. Let me go back real quick. Those came out incorrect. So then we go straight across. Here we go again. This is going to look very similar to one above. We have position 20, no bearing for velocity. But what we do know is that, again, constant velocity, no acceleration, no slope. So that first velocity is just going to be some negative value constantly for 10 seconds. And then it's going to jump up real quick because then we go to rest. So the line has to be at rest for the last part. So this first part shows a negative constant velocity. And then this part up here, right? This guy right here, that shows your velocity is 0. We're at rest. All right, so 3, starting at rest and position 0, an object moves forward, accelerate at a constant rate for 5 seconds. Then it moves at a positive constant velocity for 5 seconds, and then it remains at rest. Okay. So again, slope means velocity for this one, all right? Slope is velocity. So we start at position 0. Oop, I have the wrong thing up. Start at position 0. And then we move forward, but we're accelerating. So we have a velocity, so we're going to have a slope, but our velocity is changing because we are accelerating. So we have to curve this first line. All right, then our velocity becomes constant. So now we're still going to have a slope, but now that slope is not going to change, so it's a linear line. And then it becomes to a stop, so then our position doesn't change for the last 5 seconds, it flattens out. So this first part is a changing velocity, that's acceleration. This is a constant velocity, this linear line here, and then flatten out, that's at rest. We want to graph the same thing, all right? We're accelerating now. So in a velocity time graph, we have a slope, it's acceleration, and it tells us that for this time, we're actually starting at rest. So we have to start here. And we're going to accelerate for the first 5 seconds. So that is a linear line. Try this again. The first 5 seconds. That shows a constant positive acceleration. All right, then we move at a constant velocity. So now our velocity isn't going to change, no acceleration, no slope, so our line flattens out. And then we have to get to rest. So we have to get all the way down to rest as fast as we can, and then we go just like that, flat right at the 0. For the first part, slope represents acceleration, it's positive. The second part, no slope, no acceleration, but we have a velocity, it's a positive constant velocity. The third one, no slope, no acceleration, and we know since the line is drawn on 0, the value for velocity is 0. All right, let's take a look at 4. All right, starting again at rest from position 0, we're going to negatively accelerate. All right, so if we're going to negatively accelerate for that first 5 seconds, we have a slope, but that slope is changing, so we're going to curve, right? Some sort of curve for the first 5 seconds. All right, then we stop moving for 5 seconds. Okay, in a position time graph, slope is velocity. If we're not moving, we have no slope. So then the line flattens for the next 5 seconds. And then we walk forward at 5 seconds at a constant rate and we get back to position 0. So now we have a constant velocity, it's positive, so it's a constant slope up. So it's a curve down, negative acceleration, flat, no velocity at all, and then a positive constant velocity is the slope up. Right. One more time, we'll attack this now in terms of acceleration. We have a negative acceleration, all right? We're starting at rest. We have an acceleration, slope is acceleration, so we're going to have a slope and it's negative, so it's a linear line down. Right? Then it comes to a rest, so we have to make our velocity 0, so we have to get back up to here and then become 0. Right? This is at rest. And then we have to walk forward with a positive constant rate, so we need to have, again, another part of the line that's flat because there's no acceleration. But our line has to be above 0 now because this last part shows what's walking. We're moving again with a positive velocity. So again, the first part of the line, linear down, negative acceleration. The flat line on 0 shows no acceleration and no velocity. And the third part of the line, the flat line above the x-axis, shows a positive velocity with no acceleration. That's 1 through 4.